Hello students, how are you all? I hope you all are doing good. So my name is Aditya Jain from askIITians, and today we are going to start a topic of your grade 9th, which goes as motion in two dimensions or motion in 2D. Okay, so in the previous lectures, if I talk about the class of motion in one dimension, what you have learned that motion along a straight line, or you can say only a one particular direction is being involved in that type of motion. So that is motion in one dimension. Now what we are concerned with in this chapter is motion regarding two dimensions, means more than one directions are involved in these types of motion. So if I give you an example before starting into the main topic, that when you take a stone and tie it with a thread from one end, yeah, when you take a stone and tie it with a thread from the one end, and another end you hold it with your hands, and just you take you kind of just whirl the stone, in the circular part, yeah. So that type of motion is an example of circular motion, or you can say motion in two dimension, in which a stone is revolving around a fixed wire or fixed thread which you are holding with your hand. So in that type of motion, along with length, there is some change in another direction, yeah, or you can say there is motion in two directions, not in a single direction. So that is what is the case of motion in two dimensions. Okay, so see what we are going to see in the today's introduction lecture, or the first class of this motion in 2D. These are the topics we are going to cover in today's lecture. So that is the angle in radians. First of all, we are going to see some physical quantities. These are the physical quantities which are required to describe the circular motion basically, or you can say rotational motion, because circular motion and rotational motion are the example of motion in two dimension. Okay, so circular motion or rotational motion are the example of motion in two dimensions. So basically we are going to observe some physical parameters related to motion in two dimension or related to circular motion. So that are angle in radians, then we'll see angular position. After that we will see angular displacement, then we will see angular speed, angular velocity. Then we are concerned with the relation between angular velocity and linear velocity. Linear velocity we learnt in motion in one dimension chapter. Okay, and we end the lecture with the topic angular accelerations. So these are the basic parameters in the case of circular or rotational motion. Okay, so let's start with the angle in radians. So all of you know the basic conversion. If I say you have to convert any angle of radian into degrees, so you are easily comfortable to do it, yeah. But if I ask you what is the basic or actual meaning of radian is, then you may stop, yeah, then you may stop. So we are going to see what is the actual meaning of radian, that what is actually angle in radians defined as. So for that, I am taking a circle. Suppose I am taking a circle which is having a radius r, Now what I am doing, I am just taking this r and aligning it along the circle. I have taken this length r and aligned it along the circle like this, which is equal to r. So this length of red line is equal to r. Okay. Now if I join this extreme end of line with the center, can I say this will be also be the radius of the circle? Yes or no? Line joining any point from the center to the circumference is equal to radius only. So you can see this is a sector or portion of a circle having r at the three sides. So whatever angle now it is making at the center is defined as 1 radian. So this angle is defined as 1 radian made by an arc which is having all the three sides as r, which is equal to radius. That is defined as actually 1 radian angle which we are talking about. So suppose if I talk about the complete rotation, what will happen? You know what is the circumference of a circle? Circumference of a circle. So circumference of a circle is 2 pi r. Okay, circumference of a circle is 2 pi r. So how many number of such arcs? How many number of such arcs which are having a length r are required to make a complete circumference? The question is that how many number of arcs of length r, small r, are required to make a complete circumference of 2 pi r? Think of that. So you will find that the number of arcs required are 2 pi. So if I take a number of arcs 2 pi and each arc has a length of r, what will be the total length covered? It will be 2 pi r. That will be the circumference of the circle. So basically number of arcs required are 2 pi of length r each. And what is the angle made by each arc? It is r. Yes, angle made by each arc is r. So the angle made by 2 pi arcs will be 2 pi, yes or no? Radians. Because 1 r is equals to 1 radian. We have already seen these definitions. So 2 pi of r will be equals to 2 pi of radians. So that is the meaning that during the complete rotation about a particular point, the total angle covered is 2 pi radians. And you already know, if I take a point, if I'm traveling along a complete arc like this, so the angle covered in degrees will be 360 degree during a complete rotation. So can I say 2 pi radians, which is the angle during complete rotation, is equals to 360 degrees, the angle in degrees? Yes. So this is the basic relation or the conversion between radian and degrees, that 2 pi radians is equal to 360 degrees. 2 pi radians is equals to 360 degrees. You can use this relation to convert radian into degrees or degrees into radians, anything. Okay. Now, if you carefully observe this diagram, what is this diagram showing? You can see this arc AB started moving like this. This is 1 r distance, 1 r. Now it is 2 r, 3 r, 4 r, 5 r. This is the sixth portion, 6 r, and this is the remaining portion. Because what is actually happening, if you calculate 2 pi r value, so 2 into pi means 3.14 into r. So this will make you 6.28 r. So it means 6 complete hours plus 0.28 r means 28% of a complete hour. So this is 1, 2, 3, 4, 5, 6. 6 complete hours and this 0.28% portion. This will make a complete 2 pi r. So that is the diagram showing that 1 r is equals to 1 radian. That is the actual meaning of angle in radian. So I hope the basic meaning of angle in radian is pretty much clear to you. Okay. Now we are concerned about the next topic, angular position. Angular position. So this position is basically concerned with angles. Whatever thing we are talking about in this circular motion parameters are all concerned with the angles. So the angle in radians, radians is the SI unit of angle. Angle is always measured in radians. Radians is represented as RAD, small RAD. This is a way to show the unit of angle. So the angle in radians through which a point or line has been rotated, through which a point or line has been rotated in a specified sense about a specified axis. So suppose this is a point, or you can say this is the axis about which a body is rotating in a circular motion like this. So whatever angle it is moving through, yeah, suppose it has been rotated by theta angle. So this theta angle is defined as the angular position of that particle P. Or if I say in the case of point, suppose this is A, at some point of time it is at B and it has covered an angle of theta 2. So theta 2 will be defined as the angular position of particle at position B. So angular position is nothing but the angle. Angular position is nothing but the angle through which a point or line has been rotated in some particular direction. And in general nomenclature, we take the anti-clockwise direction to measure the angular position. We take the anti-clockwise direction from the initial position. Anti-clockwise direction from initial position. From where? From initial position to measure the angle, or I can say angular position. So I think this is clear. Angular position, if you can see in this diagram also, this green is the position. This green is the position, and this theta is showing the angular position of this green dot. This theta is showing the angular position of this green dot. So whatever angular position is there is always measured in terms of theta, which is given in radians, which is given is radians. So what is this relation showing? This is the most common relation. Suppose you know the angular position, or you know the theta, and you know the radius like this. This is the radius. This is also radius of this arc. So this thing is known as arc length. This length along the circle is known as arc length. This is known as arc length. So there is a relation which goes as angle equals to arc by radius. Angle equals to arc over radius. This is a very important relation. So from here you will get arc length is equals to angle multiplied by radius. So this is what is written here. This S equals to r theta. S is the arc length. Arc length is equals to radius into angle, that is theta. So this is the common relation, that angle equals to arc by radius. So clear? Okay. Moving on to the next one, that is angular displacement. So what is angular displacement? Angular displacement is again concerned with angular position. Angular displacement is again concerned with angular position, or you can say angle. So it is basically the angle between the initial and final position of any object rotating. So what is defined as angular displacement? Angular displacement of a body is the angle in radians through which a point revolves around the center, or a line has been rotated in a specified sense about a specified axis. You can see this body is rotating about a center point, red color point O. So this is having some angular displacement different points of time. It is having some different angular displacement at different points of time. Suppose this is O, this is the initial position of a body A. After t time interval, it has moved to position B along a circle. So whatever angle it is covering theta, theta will be known as angular displacement of that body. Theta will be known as angular displacement of that body. So it is basically the angle between initial and final position. Initial position is always taken as a reference position. So we are taking OA as the reference position or initial position. This is the initial position. So if I talk about this type of motion, suppose a body started its motion from OA and traveled a journey like this and stopped there. So this is the final position. This is the final position. Now what can you comment about the angular displacement? Angular displacement will be the angle between final and initial. This is the initial position. This is the angle, complete angle. This complete angle is 180 degree, or you can say pi radians. Okay. Now if I give you another case of full rotation, suppose this is O, this is A, body has completed a complete circle like this and returned back to point A. So the initial and final position are same. Initial and final position are same. So what is the angle between initial and final position? It will be 0. It will be 0. So can I say during complete rotation, or during a one complete revolution, during a one complete revolution, angular displacement will be 0. Why 0? Because the initial and final position of the body are coinciding. So the angle between the initial and final position is ultimately 0, and that is the angular displacement. That is the angular displacement. That's why I'm saying in a complete rotation about a point or about a specified axis, the angular displacement of that body is 0. Clear? And angular displacement is always measured in radians because it is actually theta only, or angle only. Clear? Now see a question. Yeah, you can see a delicious cheesy pizza in this picture. So pizza is given of radius 0.5 meter. Yeah, 0.5 meter radius is given of that pizza. So Rahul bought a pizza. Rahul bought a pizza of radius 0.5 meter. A fly lands on the pizza. Yeah. So fly has been attracted towards the pizza. Yeah. So fly has been landing. Suppose I'm making the situation. This is a pizza of radii 0.5 meter. Suppose a fly has landed here. This is the fly. Fly has landed at position A and walks around the edge for a distance of 80 centimeter. So it has walked around the edge like this, around the edge for a distance of 80 centimeter. So what is required? You have to calculate angular displacement of the fly, or I can say the angle made between the initial and final position of the fly after traveling a distance of 80 centimeter along the edge of the circle, or along the edge of the pizza. Okay, so first we have to calculate the circumference of the pizza, that what is the actual total length, this circular distance. So if I calculate this by a 2 pi r, so 2 pi r will give you 2, pi means 22/7, and radius is 0.5. Radius is 0.5. Yes or no? Clear? So can you say this is the 0.5 means 0.5 divided by 10, 5 2 is 10, 2. So it will be 22/7 meter. It will be 22/7 meter. Or what else can I do in this, in respect or in instead of this bigger calculation, you can use that relation that I have already told you, that angle equals to arc by radius. Angle equals to arc over radius. So that relation we can use. That relation we can use, that angle equals to arc by radius. So how to do that? So how to use that relation? Here arc length is given as 80 centimeter because this is the distance covered by the fly along the circumference. Yes or no? This is the distance. This is the arc length. This is radius. And this is theta. So theta equals to arc by radius. Radius is 0.5 meter. And if I want to convert meter into centimeter, I will multiply with 100 because both the units should be same. So it will be 80 divided by 0.5 into 100 means 50 centimeters. So it will be 8 by 5. And the theta is coming in radians. Theta is coming in radians. So the angular displacement of the fly will be 8 by 5 radians. Angular displacement of the fly will be 8 by 5 radians. That this much angle the fly will cover when it is traveling a distance of 80 centimeter around the edge of the piston. So this is how to calculate angular displacement, which is basically nothing but angular position or theta only, which is represented in radians. Clear? Okay. Now see your second question on the angular displacement again. That Tom goes around a circular track that is a diameter of 7 meter. Okay. So Tom is going around a track which is having a diameter of 7 meter. So if diameter is 7 meter, what about radius? Radius will be half of diameter. Yes or no? Radius will be just half of diameter. That will be 7 by 2 meter. It is going around a circular track which is having a radius of 7 by 2 meter. Okay. If she runs around the entire track for a distance of 50 meter, how much distance she has covered on a track? 50 meter. Then what is her angular displacement? So first of all, calculate what is the total length or total circumference of the circular track. So if I talk about total circumference will be 2 pi r. Yes or no? So it will be 2 pi means 22 over 7 and radius is 7 by 2. If you calculate it, you will get 2, 7 get cancelled out. It will be 22 meters. 22 meters. So what is the total circumference during a complete rotation? It will be 22 meters. And what distance she has covered? She has covered 50 meters. So what is the situation here? She will start the journey. She will do one complete rotation. After one complete rotation, she has traveled 22 meters. Now again, he will start the movement along circular track. Yes or no? Does the complete rotation and it will again travel 22. So it will be 44 meter. So 44 meter distance she has traveled during the 2 complete rotations. Now what more distance it has to travel? She has to travel 6 meter more. She has to travel 6 meter more. Now can I say this arc length will be around 6 meter? Yes or no? 6 meter is just like 1/4, or you can say 6 meter is this arc length remaining or the distance covered by the Tom. Because 44 meters she has already covered during the 2 complete rotations of the circular track. So the remaining 6 meter is here. Remaining 6 meter is here, and you know the radius is 7 by 2. So can I again use the formula? Theta is equals to arc by radius. Arc length will be 6 and radius will be 7 by 2. So theta will be 12 by 7 radians. 12 by 7 radians. So this is how to solve these types of questions, that when you are given some circular tracks, first of all calculate the circumference. At what is the actual total circumference of a circular track? If it was 22 meter and she has traveled 50 meters. So she has covered 2 complete rotations, and you know in a complete rotation angular displacement is 0. So after 22 meter or 1 complete rotations, her angular displacement was 0. Again she traveled 22 meter 1 complete round. So again her angular displacement was 0 after traveling 22 plus 22, that is 44 meters. Now the remaining 6 meters she has to travel. And you know in 6 meters she cannot complete the circular track. So you have got the arc length as 6 meter, remaining arc length or remaining distance. You have got the radius as 7 over 2 centimeter. So what should be the angle? It will given by the relation angle equals to arc by radius. That is 6 over 7 by 2. So that will give you 12 by 7 radians. So 12 by 7 radians is the angular displacement of that tom. So I hope this is clear how to calculate angular displacement. Basically, it is angle only, which is calculated in radians. Done. Now the third concept is this angular velocity. This angular velocity, it is just similar to the linear velocity you have read in motion in one dimension. The only difference is that linear velocity was the rate of change of displacement. Yes or no? Linear velocity was the rate of change of displacement. So angular velocity will be rate of change of angular displacement. Rate of change of angular displacement. So because we are concerned with angular physical quantities in this chapter, angular velocity means rate of change of angular displacement, and it is represented by omega. Angular velocity is represented by a symbol omega, and it will be given by omega equals to angular displacement theta over time. Angular displacement theta over time t. This is the rate of change of angular displacement. So what should be the SI unit of angular velocity from the formula? SI unit will be, what is the SI unit of angle? It is radian. What is the SI unit of time? It is second. So SI unit of angular velocity omega is radians per second. Okay. So what is the actual definition? That angular velocity is the rate of velocity at which an object or particle is rotating around a specific point. So basically it is a rate of change of angular displacement, or you can say how fast a particle is moving around a circular path. How fast a particle is moving around a circular path. As you can see in this picture, on the right side there are two particles, one pink color ball and one blue color ball. Both are rotating about a fixed point. Yeah, both are rotating about a fixed point, that is black point. So if you can see carefully, or you can see easily, that this pink ball is traveling faster. This pink ball is traveling, or you can say rotating faster. Can I say it is changing its angular displacement at a much higher rate? Yes or no? It is changing its angular displacement at a much higher rate. So that's why I can say by simple observation that the angular velocity of this pink ball is greater than the angular velocity of the blue ball. Can I say angular velocity of this pink ball will be greater than angular velocity of the blue ball? Yes or no? So this is how angular velocity is defined, that it is the rate of change of angular displacement. Its SI unit is radian per second, represented by omega. Okay. So this tells you how fast a body is rotating on a circular path. So this is known as angular velocity. Clear? Now see, question has been asked on angular velocity, that angular velocity of seconds hand, minutes hand and hours hand of a watch are. This is a very good question. Practical based question basically. First of all, second hand. A clock has three hands. A clock has three hands: seconds hand, hours hand and minutes hand. Okay. So he's asking about the angular velocity. So first of all, talk about second hand. We know second hand will complete a one rotation in 1 minute. Yes or no? Seconds hand complete a one rotation of the clock in 1 second, 1 minute. Yes or no? In 1 minute, second hand completes a one complete rotation. So in one complete rotation, what is the angular displacement? 2 pi. We already heard, we have already seen what is the complete, or what is the angular displacement in the complete rotation. It is 2 pi radians. What is the time taken by the seconds clock, second hand of a clock to complete one rotation from 12 to 12 again? Started from 12, ending at 12. It is 1 minute. Because the time period of the seconds hand is 1 minute. It is completing its rotation in 1 minute. So 1 minute means 60 seconds. 1 minute means 60 seconds. So your answer will be, this is the total angular displacement. This is the total time taken. So this will give you angular velocity of seconds hand. So angular velocity of second hand will be given by pi by 30 radian per second. Pi by 30 radian per second. Is this clear? Okay. Now talking about the minutes hand. So it is carefully, or if you are observing, minutes hand take 1 hour to complete one rotation. Yes or no? It starts from 12. This is minute hand, and it will take 1 hour to again come back to 12. Yes or no? So it is taking the 1 hour to complete one rotation. So what is the angle in one rotation? It is 2 pi radian. What is the time taken by minute clock? It is 1 hour. 1 hour means 60 minutes. 160 minutes means 60 seconds into 60. Because you have to take the time into seconds. That is 1 hour is equals to 60 into 60. seconds, because 1 hour is equals to 60 minutes and each minute consists of 60 seconds. That's why 60 into 60. So your answer will be pi by 180, pi by 1800 to be precise, radian per second. This will be the angular velocity of minutes hand. This will be the angular velocity of minutes hand. Clear? Now talking about the final hours hand. So how much time an hour hand take to complete one rotation? Suppose it starts at 12 a.m. It again came back to the same position at 12 p.m. Yes or no? Hours hand will again come back to the 12 position at 12 p.m. So what is the time span or time period? It is 12 hours. Time period is 12 hours to complete one rotation. So what is the angular displacement in one complete rotation? It is 2 pi radian. What is the time taken? 12 hours. So these hours should be converted into seconds. Hour into minutes means into 60 means seconds. 1 hour equals to 60 minutes and 1 minute equals to 60 seconds. So this is the conversion. So this will be 6. So it will be pi by 21600 radian per second. So you can see the angular velocity of seconds hand is the highest. Yes, so angular velocity of second hand is greater than angular velocity of minutes hand is greater than angular velocity of hours hand. Yeah, this is also possible. This is also practical observation also. Yeah, because seconds hand rotate very fastly because it has to complete one rotation in 60 seconds, while minutes hand take 1 hour to complete one rotation. So it is moving slowly in slowly with respect to the seconds hand. And what about hours hand? Hours hand take 12 hours to complete one rotation. So its angular velocity is minimum or least in comparison to the seconds and minute hand of a clock. So this is how to calculate angular velocity, that total angular displacement over total time taken. This will give you the angular velocity. I think this question will complete all your doubts. Yeah, it will solve all your doubts regarding angular velocity. Thumbs up, guys. Yeah. Okay, now the next topic is relation between angular velocity and linear velocity. This is another important concept, that linear velocity we have already studied in the motion in one dimension, that is represented by v. So linear velocity is change of rate of change of displacement, which was given by dr by dt, which was given by dr by dt, or you can say ds by dt, ds by dt according to us. And angular velocity omega is given by d theta by dt. Yes or no? D theta by dt. So this is the actual meaning linear velocity. This is angular velocity. And if I say u naught theta equals to arc by radius, as angle equals to arc by radius, suppose the radius is r, this arc length is s, and the radius is theta. So can I say this angle equals to arc by radius? So from this, can I say arc equals to angle into radius? So if I replace this value in this equation, what can I see? V will be equal to d by dt. In place of s, I'll write r theta. And you know this radius is constant for a particular circle, so I'll take constant out. It will be d theta by dt inside. And you know what is d theta by dt? This is omega. So this will give you v equals to r omega. V equals to r omega, or you can say v equals to omega r. So this is the relation between angular velocity omega and linear velocity v. Yes, or you can say this is a relation between motion in one dimension and motion in two dimensions. Yeah, you can say linear motion or angular motion or circular motion. This is the relation. Suppose, what is the example of this? I can say, suppose this is a body. This is its center. Suppose there is a fly. This is a fly at this point, which is at a distance of 2 meters from the center. Which is at a distance of 2 meters from the center. You want to know this linear velocity of this fly, or I can say tangential velocity of the fly. So how can you calculate the tangential velocity of fly? It will be v equals to r omega. Omega is constant for a particular body or rotating. Yeah, so it will be given to you that the complete body is rotating about a center with this much velocity. So if you know the distance from the center, that is r, and if you know the angular velocity of the complete body, can't you be able to find the linear velocity of that part? So this is the basic advantage, that how to convert angular motion or circular motion into linear motion. If angular speed is given to you and you know the center of, or you know the distance of the body from the center or from the axis of rotation, you can directly calculate the linear velocity or linear speed of that particle. So this is how it is shown in this graph also, that v equals to omega r. And you can see in this diagram also that this angular velocity is about the center like this, which is giving you the rate of change of angular displacement that is concerned with the circular motion. And what about this linear speed? Linear speed is the tangential velocity at any particular point of time. So that will be given by v equals to r omega. V equals to r omega. Okay. Or to be more precise, if I show it in a vector form, basically v is equals to r cross omega. This is a relation which you will use in higher classes, that v is equals to r cross omega, where r cross omega is the vector product. This is the vector product which you will see in class 11. Yeah, this relation you will observe in higher classes. So I think the basic relation is the v equals to omega r, where omega is the angular velocity and r is the distance from the center or axis of rotation to that particle. Clear? Okay. Now see, the final topic of this lecture is the angular acceleration. Angular acceleration. So we have already seen acceleration in the case of motion in one dimension. That what is acceleration? Acceleration is the rate of change of velocity, or you can say rate of change of linear velocity. So same will be the angular velocity, angular acceleration, with the only difference that in terms of or in place of linear velocity, this is the rate of change of angular velocity. Yes, so that is defined as angular acceleration. That angular acceleration is the rate of change of angular velocity. So angular acceleration is generally defined by a symbol alpha, and it is the rate of change of angular velocity. It is d omega by dt. What should be the unit of angular acceleration? The unit of angular velocity is radian per second. This is divided by time. So it will be radian per second square. Radian per second square. So this will be the unit of angular acceleration, that is radian per second square. I think this is clear. Again, it is a vector quantity. It is a vector quantity along with angular velocity also. Angular velocity is also a vector quantity. Angular acceleration is also a vector quantity whose unit is SI unit is radian per second square, and which is defined as the rate of change of angular velocity. Okay, so this is I can say the simply analogous to the motion in one dimension. What you were observing as acceleration, it is angular acceleration here. What you were observing linear velocity, it is becoming angular velocity here. What you were observing displacement in one dimension, it is now angular displacement in the circular motion or motion in 1D, 2D. Sorry, yeah. So that is the thing, or that is the basic parameters we have learned, is the angular speed, or you can say angular velocity, angular displacement, and angular acceleration. Okay, the thing is clear. Now you can see this body rotating with some velocity. So its angular velocity is constantly changing. That's why it is known as to be in angular acceleration. So if body is moving with constant angular velocity, suppose if I say if angular velocity is constant, if omega is equals to constant, this implies angular acceleration will be 0, because it is the rate of change of angular velocity. So if angular velocity is itself constant, then there is no meaning of angular acceleration. It will be again 0, because there is no change in the angular velocity. So I think this angular acceleration is also clear. Okay. Now there are two more questions. Now see, an ant is sitting at the edge of a rotating circular disc. So there is a circular disc, which is a disc like this, plate you can observe. So it is sitting at the edge. Ant is sitting here. Its angular velocity changes at the rate of 60 radian per second. So rate of change of angular velocity is that angular velocity is given as 60 radian per second. How much time it is taking for that change? It is taking 10 seconds. So it is being asked what is its angular acceleration during this time. So it is a directly formula based question. Angular acceleration will be omega divided by time, rate of change of angular velocity. So it will be 60 radian per second over 10 seconds time interval, which will give you 6 radian per second square. 6 radian per second square. So the angular acceleration during this time interval of 10 seconds is 6 radian per second square. Clear? Okay. Now the next question is this, that a body is whirled means rotating in a horizontal circle of radius 20 centimeter. Okay, so there is a body which is moving in a horizontal circle of 20 centimeter like this. It has angular velocity of 10 radian per second. So angular velocity is given as 10 radian per second. That means omega is given. What is the linear velocity at any point on the circular path? So it is asking about you linear velocity v, and we know our radius is given as 20 centimeter. SI units will be meter, so it will be 20 by 100 meters. That will give you 0.2 meters or 0.2 meters. So the radius is 0.2 meter. Angular velocity is 10 radian per second. So what should be the linear velocity? We have already seen the relation between linear velocity and angular velocity, that v is equals to r omega. You know r is 0.2 meter and omega is 10 radian per second. So the answer will be 2 meter per second. This is the linear velocity at any point on the circular path. So that's how I was saying that if you are given angular velocity and if you are given any radius, then you can easily calculate linear velocity from that angular velocity by the relation v is equals to omega r or r omega. So I think all concepts are clear. What we have learned today, we have seen what is radian. One r length is equals to 1 radian. Okay, and 2 pi radian is equals to 360 degree. That is the basic conversion. Then we have seen angular position and then angular displacement, which is the angle from the initial position to the final position in a particular direction. And for a complete rotation or for a complete circle, the angular displacement is always 0. Okay, then we have seen angular velocity, that is the rate of change of angular displacement. Then we moved on to angular acceleration, which is defined as rate of change of angular velocity. So these topics we have covered. I hope all these topics are clear to you. Yeah. So if you, in case of any doubt, you can refer to Ask IITians website. There is some doubt forum. Yeah, doubt forum is present on Ask IITians website. You can post your doubts there and get it resolved by the expert faculties. Okay. So we'll end this session here. Thank you so much. Stay safe and enjoy. Bye-bye.